Look how easy that is. That was so easy, and I just missed the whole warm-up.
All right, now we got to do it again.
Yeah.
Nice try. All right. So the idea is that we have these equations, and from these equations, we can ask questions. If you get this, if you understand that, like, this means how far do I walk for $14, that's big. Like, you can do, this is an end of the unit expectation, not like a middle of the unit expectation. So you're doing well if that's how far, or if that's your understanding right now. Which one of these three plans was more difficult to come up with a question? Two. Why two?
It's just kind of confusing because, like, the parentheses always kind of throws you off.
Okay. It's kind of figuring out which one of these represents kilometers, right? That's why you can go over here and you can be like, wait a minute, my rate is always the coefficient of my independent variable. So here I go, coefficients first. There's the coefficient. This must be my independent variable. That's how far I have to go. She wants to know how much money she's going to make. So yes, I would agree that this one's harder because you're like, here we know that's money. A lot easier to find. You don't mix it up. Ben.
So the way I looked at it was like, since there's no x in plan 2, I mean there is, but like there's no x like in like plan 3.
Yep.
I just figured that was the x.
Yeah. And again, you can come back and look at this and be like, oh yeah, that's my y-intercept, that's my rate, that's my independent variable. Grades are in the grade book, totally updated. And today we're looking at equality. And we're using something called coins and pouches. I think you guys are going to like it because it's a little bit different way to look at algebra. But before we start, if I talk about equality and my fist is the equals, what do we know? Yeah.
That the right both sides are.
They're equal. They're the same. Do they have to look the same? No. That's proof right here, right? Doesn't look the same. Doesn't look the same. They're going to look different. I might have it might be more like this, right? Where it's like all these numbers over here, one number here. But what happens if I add something to this side? What do I need to do over here? I need to add the same thing so then it becomes balanced again. So equality tells me it doesn't matter what I do as long as I do it to both sides and it will still be equal. Okay, if I add 2 apples over here, I can add 2 apples over there. So we're looking at that equality, but using coins and pouches. And I have the most stimulating, amazing video to launch this. It's really good. You guys are going to go home and be like, go to Google Classroom and be like, I want to see that video again. Trust me, it's that good.
Unless it's talking about how to make brownies. I don't want to do it.
Okay, Lulu.
Is it that one not like that when we came in
Yeah.
for the project?
All right. No, it's not that one.
Oh.
Okay, Lulu's over here. Remember, guys, wait, Lulu, this is important because you're going to like this. Semicircle, half circle, paper in front, one conversation. Lulu's the boss. So, that means, Lulu, they're talking, call them on it. Over here, Isaac, you're the boss. So, one conversation. Okay, we go. Get your homeworks out. That's a good answer, Max.
Wait, you can use the cube.
Wait, is there Mrs. Bosses and Mr. Bosses?
No, it's an inside joke.
Okay.
Mr. McFarland, should I work on the graph?
I said that you can use the graph to visualize, and you can use the table to find the rate and record.
Get out there. Don't be copying it up there. Do your own work. Because that's not going to help you, Michaela. This is actually a good one, too.
Was it page 64?
No. It was page... What page is it? 69. See, that's what you did. You wrote it down so messy you thought it was a flower. That's awesome. Isaac, here.
Oh, yay. I get to hold the thing. I get
Be
to wear
appropriate,
it.
please.
I will. Alright. So for the table, I said you could have the money go down and the t-shirts go up, and this can help find a specific number. For an example, if you want to find 5 t-shirts, you can help find that, or if you want to find 5 million.
I said
Actually, find
you
yours.
can use a table and a graph by applying the point 80, and then multiply that by the rate, and that's track 20.
Okay.
I do know something like about. I think it's going up at 60. Warren. What do you think, Warren?
Oh, I said this.
Don't attack.
Instead of counting by 5s, we can count by 20s.
No. Oh my god.
Why 20?
Because it would make it a higher rate.
I just multiplied by 6.
Hey, you were supposed to do
Good point.
that.
And then for the graph, I said that you can visualize the rate, DV, and IV in the graph.
It's literally both
Visualize
ways.
because if you
One of the points, it's
have a graph,
20, no, 38.
you know, this is the
So
IV and this is the
it could be the $30 shirt can I buy,
and this is rate.
or it could be if I have 80
Where's the
bucks,
y-intercept?
how many shirts can I buy? Did I say that right?
How did you get to read the house?
You happy?
Yes.
I can't read
I
that.
can't read that.
So like for instance, you guys.
It looks like increase.
Alright.
I said 50.
She is looking for the amount
You
of
reach into the
t-shirts.
pocket. Hold on,
Sophie
I got
is
80
looking
bucks. How much
see
can I
how
buy?
much
Like,
it would cost
he
for
wants to
15
blow
t-shirts.
all his money every time. he does
Yeah.
it.
Hey, it's the same
Right?
thing.
You guys are probably not.
And
said-
she is looking
And he's
to
not
see
so
if
much
she
that way
can
anymore.
buy
He's
30
starting to figure
t-shirts
out
for
why.
$80.
So yeah, mine were pretty much the
So you guys
same.
might think like,
What I said is how much
I need to
the
buy
price is
20
for
shirts,
15
how much are they?
t-shirts.
instead of like I need to spend all my money.
Warren, stop attracting the camera.
You back with Lulu?
Anyway, and then for 1D, I'm pretty sure you have basic idea. Don't
What I
Warren.
said for what I said for 1D was she's looking for how much money, how many teas she can get. I said she.
Alright, so
Pay attention.
alright, so let's say that this is how much you want. So wait. Alright, so let's say that she wants to buy 30. And then it costs $80. You got a rate there.
What? Wait, pay attention. What? Where? Why? Potato Man.
Pay attention. Anyway. Why is attention? Good point. Anyway.
That was pretty cool.
What?
Let's gather online.
That was pretty cool.
So that's it. I'm good. What?
Anyway, it should work.
Okay, I'll do it. No. Do it very slowly. It's like a laminator or something.
All right, guys, wrap it up.
Hey, Mr. McFarland, you might want that.
Thank you. All right, so today, thank you, Lulu, for being a fill-in. Appreciate that. Today, coins and pouches, looking at equality. I'm going to play this video. Like I said, it is amazing.
Is it dope?
It's amazing.
Yeah, dope.
Oh, I think it's like dope.
All right. Shh.
Oh.
This is a
One day, the king of Montarac received a note from his cousin, a king in the distant land of Karatnam.
Dear
Guys.
cousin, I would like to congratulate you for winning the archery competition that was held in my castle last week. I reward your outstanding performance with 11 gold coins. The coins are equally divided in these 2 sealed pouches.
I'm to receive 11 coins. 11 coins cannot be equally divided in 2 pouches.
I almost forgot. The pocket change. The king ran out of sealable pouches.
But how do you know the coins are equally divided in those pouches? The pouches are sealed. Nobody can see how many coins they contain.
I was told that each pouch contains the same number of coins, and I was assured that all 11 coins are there.
We'll see about that.
Can you figure out how many coins are in each pouch? How can a visual equation help you?
All right, so a visual equation. This is going to be step 1 for you today, is creating your visual equation. So here I have the 2 pouches, 5 coins, and 6 coins. So I need to think about, instead of having the coins and pouches right now, what is this value here? 11. And then I bring over the equals. What's this value? So now, these, do we know what they are? No. That's the part now, we might have done the math already and figured it out, because it's not difficult. But we call these x. So if I have one x and then I have another x, how many x's do I have? And then, in order for me to have this be the same, what operation do I put in the middle? Okay. This is step 1. Before you solve anything, I want you to go through and above your coins and pouches, I want you to do a visual equation. This is our visual equation. Then you can solve it however you want. So my visual equation looks like this, but I know something about equality. What did we say about equality? Whatever I do to this side, so I'm going to try to make this easy. So I'm going to get rid of 5 on both sides. I'm going to get rid of those 5 and those 5. So now I have 2 coin pouches and how many coins? And because each pouch has the same amount, there's 3 in there, 3 in there. So that means that my answer would be x is 3. Each pouch has 3 coins. So what would happen if I did this? Yes, this is your visual equation. So what happens if I did this? And my pouches are really good pouches. I stick to mathematical shapes. Triangle, circle. That's the extent of my, right there.
Like those medals that skiers get, like
So, what happens if I did this? Talk to your group. What changes? Go, talk to your table.
There's one pouch. Yeah, so there's one pouch.
You just put
They're multiplying by one pouch. So you have to subtract the 5.
Each pouch has 11.
So Ben's saying still subtract the 5. Okay. And then what else did you do, Ben?
Well, there's one bag, so it happens 6 in one bag.
So you said then I'm going to get rid of a bag on each side too.
Yeah.
So now I have one bag equals 6 coins. So pouches, I can treat pouches just like coins, except, you notice this is called X, This is called 2x. We call these like terms. These are, I can add these and subtract these. But I can't do this. I can't take away an x and then take away coins because I don't know how many are in here. Does that make sense? But if I have an x here and an x here, those can cancel out. Does that make sense, Jackie? So the equality. How does the equality help you in answering the question? Isaac. How?
Because what happens is that you do process it over the error, not eliminate.
No, that's kind. Yeah.
You get rid of numbers, and as soon as you come to a question or a simplified version of the question, it would say, like, for example, 3x equals 9, and then you do division and find out.
Exactly. So it allows me to simplify and get rid of things that are kind of the same on both sides. And if you notice, here it's easy to get rid of these 5 coins and these 5 coins because it's like, oh, I see those 5 and those 5. But when you have numbers, it's no different. How do I get rid of the 5 here? Subtract 5. If I subtract 5 from this side, what do I do over here? Subtract 5 from this side. So it kind of gives you that idea like, oh, that's why it works. That's why whatever I do to one side of the equation, I have to do the other. That's why it works. These are linear because that's a rate. It's a coefficient to a independent variable. All right, go ahead. Work on. Some of you have already started. Kendra couldn't wait. She was like, "I'm going." No, it's okay. It's fine. Remember, step 1: do all 6 visual equations. Write down the visual equation. Then you can go back and solve. Okay. And that is on your paper that you collected at the door. And then I have on the board the next part, which is extension problem 51. And then by the end of class, we will get to part B as a group.
I think so.
Oh, okay.
Alright, so what'd you get for 1?
I don't know. I'm not done. Am I supposed to eliminate 4 on the other side or subtract?
We're not supposed to solve.
Huh?
We're supposed to do
No, remember what I did? I put
and then
I put x
after you do all 6 of the visual equations, you do the
That's
Okay.
visual equation.
1, 2, 3,
Alright, so
4,
what I
5,
got was
6.
3x plus 4 equals 10.
I started on the wrong
And then I
side.
got 2x plus 4
First step
equals
is I want you to
12.
write down.
Wait, I'm a little bit confused.
So how many coins do we have?
On 2.
Wait, did you say 3x?
Yeah,
So you got 10.
No, but
there's 3 pouches.
Equals.
No, it's
Which
not.
side
What are
are
these
you
going to
on?
turn into?
There's only
1.
2.
There's 3 pouches.
I'm on 1.
Well,
Oh,
what
I'm
do
a
they
little bit
represent? What do they
confused on
represent?
that
by
No,
demo?
on the second one I got 2x plus 4 equals
But like, are they?
Okay,
Do they
how
go
many do I have?
together?
3x.
No, so here, let me tell you. So
Plus.
1, the pouches
Okay.
equal x, okay?
This is
And
what I
none
want
of these
you to do
problems are
first,
linked together,
and come
okay?
back and solve.
Yeah.
So that'd be 3x plus
I want you to
4
write the
equals
equation
10.
above it first. Then
Yeah.
come back and solve. Does that make sense?
Yeah, but what about number 2?
So number
Because they're
2,
separated, so wouldn't it be different?
so you would do 12 equals 2x
Plus 4.
plus 4.
Which I can
So basically you're just saying what this is.
Okay. That's 3x equals 12.
This one?
Because there's 3
3x
bags.
equals 12. So basically you're just trying to solve for x.
Yeah.
That's really.
Wait, what
Yeah, now when I
about
put-
number 3?
So number 3 is. So look at it.
And I just looked at
So
it.
there's 3 bags.
So it's 3
So
bags, so
that's
3x. And then count
But
how
there's
much.
2 more bags.
Yeah, but that's the. Look after the equals.
Yeah.
Yeah, but wouldn't they change anything?
No. Because the 3x is representing this stuff over here.
Yeah. So So whatever's in these bags equals what's over here.
So there's 12 coins over here, so there's 12 coins plus 2 pouches over here.
Yeah.
And so there you would
Oh. You get it
3x
now?
equals 12.
No, but wouldn't it be 12 plus 2? Because there's 2 pouches. I don't know.
No, there's 3 pouches on this side, so 3x equals 12.
Yeah.
But what about those 2 pouches?
Those don't matter.
Because we cross them out because of the other stuff.
Yeah. You just
Okay,
Why don't we-
for number 4. You haven't got
Alright,
that
so
far. I'll
wait. So that's 1, 2, 3, 4, 5, 10, 15, 20, 25, 30.
35,
There's
right?
3.
Oh, damn.
So there's the same.
I'm confused.
So 3x plus 3 equals
Oh my god.
You forgot
35.
your 2 pouches on this side.
Wait, so they're 2x.
Mm-hmm. So it's 3x equals 2x plus your 12. Does that make sense?
Told you so.
That doesn't make sense.
Why?
Because it's on the other side of the equals.
But I had x on one side and I had 2x on the other, didn't I?
Yeah.
Yeah. You can have x's on both sides,
Sorry.
right?
Yeah.
Those are called like terms. Those are terms that I can combine and do stuff with. I can't take a number that has an x and try to put it with a regular number. That doesn't work because x is unknown.
So 3x equals 2x plus 12.
3x equals 2x plus 12. Yeah, that's it.
That was weird.
Told you so.
So this one is 3x plus 3 equals x.
That one's confusing. 6 is
2, 4, 6, 8, 10, 12.
What's 3 times 7? 21.
I don't think it was.
You do win the smallest pencil award.
So the equation is 2x plus 21 equals 5x plus 3. So 5 is 3x plus 3 equals 2x plus 12.
Crossed off the 2 backs on the left, so I crossed off the 2 on the right, then I crossed the 3 coins off on the right, so I crossed off the 3 on this side. So then I counted all the coins that were left, and then divide them by 3.
3, 6, 7, 12, 15.
Okay, but hold on. Just pause for a second. So you have 3x equals 2x,
Equals
right?
5x plus 3.
But the problem is,
Okay.
if you look at that,
So it'd be 18.
what you see is the same.
Alright, so do we solve them now? I'm pretty sure we solved them.
Yeah.
Now that we solve them,
solve them yet?
Aha.
You're not supposed to. You weren't supposed to do that first.
Yeah, I did the equations and solved them already.
20 minutes. Keep going.
I did that with
Doing well today. Just keep going.
That's obviously 2.
So now you have one bag equals,
Wait, what?
boom.
Yeah.
X.
So how many coins are in a bag? Well,
Wait, so
does that make sense? Especially if you look at it, right? 12,
I'm not
12,
following.
12, 12, 12, 12.
So are you on the first one?
Yes.
Oh, so count here. 2, 4, 6, 8, 10. Alright, now subtract 4 from 10. 6. And there's 3 bags, so there's 2.
Oh, okay.
So look. Look this out. This is how I did it. 4, yeah, so 4, and then
Now,
2.
it's pretty cool when you look at it. Basically, if you think about it, like, this looks pretty complicated. 3y plus 3 equals 2y plus 12.
Alright, so
And boom, you get the answer. Like, you're already
2,
solving.
4,
This is like
6, 8, 10, 12.
this is like algebra.
How are you supposed to know what?
That's what I'm trying to figure out.
What?
What are you trying to figure out?
3.
Like
Number
something
3.
too fast.
Wait,
That doesn't
you're
work.
so smart.
So what's the saying that you, so remember, the thing,
Think.
remember Isaac's process of elimination.
Expand.
So what can I,
Wait, is X 12 for both of them?
So what does that
The
mean?
X's.
One bag
There's
equals.
only one X. There's two X's. All.
Does that work?
Are there
12,
two
12, 12. 12, 12.
Oh wait. Yeah, there's two X's.
That's not, but they're all the same number.
Yeah. Oh, wait, what?
Same. That's true. Okay.
What are you thinking about here?
Number
So
three.
I was just confused about like, what would this other X be? Because like you already have the like, how are you supposed to figure out what X is here?
So Isaac said process of elimination, right? So can I eliminate things?
Yes.
What can you eliminate?
These two bags.
2 bags. So eliminate 2 bags.
Just how low do you have to?
No, you don't have to. That's what's great. They're like terms. You have 2x and 3x. Those both have an x in them. They're like terms. They're treated like they're numbers.
Since you eliminated 2 bags, would you eliminate 2x in the problem?
Yep. So now, how many bags do you have?
It is 4.
3.
No.
Yeah.
No, I eliminated, hold on. If I eliminate 2 bags on one side, what do you know about equality?
Oh, you're supposed to
Oh, you have
eliminate 2
to
bags on the
eliminate
other
2
side.
bags on the other.
That's what equality tells you, right? Like, do the same thing both sides. So now what do you have? 1 bag equals 12 coins. Now, does that make sense?
Yeah.
12,
Wait.
12, 12. 12, 12.
So there's
12.
12 coins in each bag?
Yeah. Does that make sense?
Yeah, sort of.
Well, okay, well look.
That makes
12
so
plus
much
12
sense.
plus 12,
Yeah.
36.
Yeah, that makes sense.
12 plus 12 plus 12, 36. Remember, that equality tells me if I have like terms, which in this case is x, right? I can, whatever I do to one side, I can do the other side of like terms. Okay?
What's 27?
Yeah.
Is it 9?
Yeah.
Okay. I cannot see the like
Right. So you
division.
get rid of those 2 like terms. Get rid of those 2.
Hold up.
And then subtract 3.
So we have to eliminate 2
Nice
on
work.
this side.
Wait a second.
That's really good. One thing you might want to start trying to do mathematically
5, 10, 15, 20, 25, 30.
12.
Your dad talked to me about that.
How'd you get 9?
Because what's going to start happening is math is going to get harder and harder.
30
Oh,
minus
wait.
3 is
This year?
27. 27
Yeah,
divided
yeah.
by
Then
3
you get
is
messy,
9.
it gets really hard to go back.
Also,
and
3
check
times
your
9 is
work.
27.
I don't need this negativity.
You're killing my vibe.
Yeah, that's what I want you to do. Right. So,
Is that you saying?
Yeah.
Wait, you can eliminate 2 bags.
I want you to do this.
Alright. So there's 1.
You did that.
You can?
I'm talking. That's a good.
She does eliminate 3 coins on this side. Alright, so X equals 9.
I got 9 for this.
I did that one wrong.
It should be 9.
Yeah, it's 9.
Yeah, I got 9 too.
I don't know. I know.
Wait, guys, how do we eliminate these many bags? Oh, we have to eliminate it on this side. I see. So,
You can also eliminate 3
wait,
coins.
how did I get 21?
You can eliminate 3 coins. Well, you can eliminate 3 coins too.
What? Why would we eliminate?
I know, because they have.
Eight. 8 times 2 equals. Oh wait, 9. It's 9.
They're
Again.
not all 9. It's not.
Wait, no, why would we eliminate 3 coins?
Because you can. It's process of elimination.
I see. Okay, so what's 21 minus?
That way you don't have to do a bunch of freaking
Wait,
math.
so you guys got 29 for these coins, right? Or 21.
Yeah.
Okay.
No, I got 18. You're not supposed to count the
Any
eliminated.
questions about the coin?
I know.
Okay, what I like about it
See the 18?
is that you look
Yeah,
at
yeah,
the visual equation,
Wait,
like,
no.
oh, that looks pretty
Yeah.
hard.
How are they all
And then you do
9
it
though?
coins and times, and you're like, wow.
This doesn't make any sense.
Already on B3.
And it should give you an understanding
Bro,
of why it works.
We don't need this negativity.
Yeah, I feel
God.
like you're just giving us activity. And I feel like you're making fun of us.
Jeez, I know. Wait. There's no possible way those are all 9s. They're all 9s, aren't they?
I didn't think so.
Yeah, it was like
I'm not done.
4 and 5 are.
4 and 5
Lulu's
are.
got the answer right in front of her.
4 and 5 are.
I do.
Yeah, you do.
18. It's right there.
I
Right?
didn't. I thought I had to like
Oh.
do one of them.
No, think about it. Think about it.
It's 18.
No. How would I get rid of the 3 that's being multiplied?
You subtracted? No,
Being multiplied. Divide it. So I divide this side by 3. That turns into 1. Perfect. Divide this side by 3. That turns into 6.
You were thinking 2. Yeah.
Dude, I was
So does that make sense, Lulu?
Yeah, I know.
You had it right there.
That's dumb.
Get going on 51.
Alright.
That's pretty good. I like 51.
Alright, smart guy.
Oh, I did B3. So I was supposed to do the extension first?
I guess.
Yeah, you're supposed to do B as a group. Why does it say all as a group? Wow. Where are we supposed to do her learning? Page 51. I meant 81. It says 81.
Yeah.
It says 58.
It says 81. You're supposed to do extensions. What the heck? There's a freaking.
Humorous.
What?
Femur.
What? Yo, what's going on, fam? Problem what? 51?
I'm gonna try to do one of these cool looking A's.
Cool looking A's.
Why doesn't it ever work for me? I do everything they
The
do.
average weight per adult is 150 pounds. Is that correct?
Yeah, that's it.
Probably.
Yeah. So once you're done A, go to the extension.
Wait, B first on that? There are multiple answers for extension A.
Yeah. Isaac, Warren, focus. Come on. That goes in exit tickets, warm-ups. Hold on, let me pass this up.
This is quick. I have 27.5 for kids. Would you round that up to 30 because you can't have half a person? Or can you just say there's like...
You probably round down, right? Because they're talking about...
Is that okay then if it isn't exact? Because it would take 27.5 kids and 10 adults to reach 1,500 pounds.
Yeah.
I can do that?
Yeah.
Okay.
Is that what...
So I'll just round... So
It is. Okay. Shh. All right, guys. Hey, some of you guys, it's a photo shoot, right? For poetry. Okay, hold on. I just want, before you leave, because you warm up an exit ticket.
There is no wrestling practice tonight for middle school wrestlers, and there is a meeting right after school tomorrow afternoon in the commons area. So again, you do not have practice tonight.
All right. Homework. 5, 6, 7, 8, and then, okay, on page 70, and then summarize your understanding of pouches and coins, or coins and pouches. You don't need to do it right now. Miss Fisher needs you down in the auditorium. You publishers.
Hi, guys.
You guys, you want to hear something really cool real quick on your way out? You know, Miss Frizzy's getting published. In Spanish. Boom!
Are those like single problems?
I know, it's not very big too, but it is to me because my wife works part-time, we're poor.
Wait. So, are those like single problems?
Yes. No, there's no ABCs, dude. 5, 6, 7, and 8. Kendra's been working on it for about 5 minutes and she's almost done.
Wait, so we can leave now?
No, only publishing kids.
What are publishing people?
It's in Miss Fisher's class.
Yeah, I wasn't here when we published.
So I give around 27.5 just to 27. One of the kids is a little chubbier.
Yeah, go ahead, finish up on your exit ticket. Yeah, you can go ahead and do that. Oh, James dropped the smallest pencil in the school.
Smaller!
David.
No. I have one that's literally some.
I made one I whittled with a knife and now it's literally down.
I have one that has that much pencil left.
Figure that's just from canceling those out.
Anthony.
There was no beating my small.
So look. You did it right here. Look, you did it.
Dude,
He was doing it. So you.
No, I haven't. I got to the point where I had to start using like little stuff.
Taya, not here. Isaac. Okay. Just gonna give you some feedback here.
Got it.
Okay, that was not bad. You need to read the problems and write down all the. These aren't even ones that were in the problems.
Oh, there were problems too?
Yeah, read it. That's where you get your vocab. Restate the question, restate. So you lost 2 points right there because you're not restating. And then always show and be specific.
Got it.
So remember that. I'm trying to get you guys ready for like CMAS and stuff like that because that's what CMAS is like.
Your first or second?
I think it's a first. Right. So a 10 out of 14 is good.
I'm in your turn.
I probably bombed it.
Lulu did not. No, Streeter, you aced it too. So you can look at her and see, look. See how she gives an example and then explained it. And then here, restating. The pattern of changes between two variables in a linear relationship appears. So she's literally just restating it every time. She's good at it.
No, my dad always said, give them a lot of information because otherwise, if you miss something, you can mark your grade down.
Teachers, would you please attend the 7th grade students who are having their poems published to the gym?
Wait,
Published poems.
To the gym
Like
who are
sold?
having their poems published. Thank you.
Not exactly. No cash. You wish.
Well, I don't wait.
Then why would you do it?
You what?
What's the point?
No. I don't know what Liam's talking about.
What's that number?
14. It was a 16, then I realized it was only out of 14.
No, I'm good with the 16.
No, you can't get a 16 out of 16 when it's only 14 points.
Exactly.
Sorry.
Or you know, it's actually always best if you have a test where you have 10 questions and you're really hard and intentionally get them all wrong so you can just put a 1 in when you get 0 out of 10.